I'm going to introduce our honored guest here in a moment. And I'd just like to acknowledge that it is possible to change the world. And I think Wayne Rosing is one of those people that not only has changed the world, but continues to do it in new and different ways. Mr. Rosing was involved as a key player in several landmark projects in the computing industry, and he really is a historic figure. It's not part of his bio, but he told us that he actually helped design the first mouse, so that puts a little bit in context. He was vice president of engineering at Apple Computer in the early 1980s, where he helped create the Lisa and the forerunner of the Macintosh. He then went on to Sun Microsystems, where his team developed Java. From there, he met Eric Schmidt. Eric Schmidt took him over to a new startup called Google, and he was vice president. Pardon? Oh, other way around. And he was vice president of engineering at Google for 6 to 7 years. So without further ado, here's Mr. Rosing, and he's going to give us a PowerPoint presentation on his current endeavors.
Welcome, everybody. It really is life. There's more people here than there would be at LCO this time of Friday. They're all getting ready to go surfing or something. I'm going to talk about Las Cumbres Observatory Global Telescope.net for a few minutes. And if I say something that absolutely needs to provoke a question from you, tackle me and I'll answer it, okay? But then we're going to have a long Q&A afterwards. Las Cumbres is sort of Spanish, I think, for the summits. And I happen to live in a community in the Western Bay Area, west of Los Gatos, up in the mountains called Las Cumbres. And I founded a little observatory in 1992 there. Started at my house, and it's sort of gotten a little out of control. And so that's what we are. We're a nonprofit and funded by a foundation. And what we're doing is, guess what? We're building a global network. So I'll tell you a little bit about us. First of all, our mission, from my point of view, what I have set out to do is build from scratch a scientific institution that's dedicated to time domain astronomy, meaning things that happen fast, things that explode, stars that explode, or events that typically happen and you need a response from seconds, from when a satellite might tell you something is happening, up to, say, the first 2 weeks. After the first 2 weeks, sort of all the other telescopes in the world, if something's important, can kind of get on it. We don't have an advantage. But in the first 2 weeks, or better yet, the first 5 to 10 hours, we'll have a unique advantage, actually developed right here in Santa Barbara, which is the ability to have telescopes essentially virtually all over the world, so we can, if clouds permit, we can see things. The second aspect of our project is to use what I consider to be the innate interest in the sky that's almost built into our genetic code as a way to attract people to learn about science, learn about critical thinking, learn about data-driven decision-making. And so there's an educational agenda that I think we're going to pitch to what I call learners of all ages. I will often say kids, and that's code for grade school kids. But I really do mean learners of all ages. This project sort of got off to a good start in 2005 after I retired from Google, and then I became refired on this project. And we had the unique opportunity to acquire membership in a nonprofit corporation that had been put together by a similar a gentleman by the name of Dill Fawkes in England. And he had built two 2-meter telescopes, put one in Hawaii and one in Australia, with the idea of providing online telescopes for British school kids to use during the British school day. So obviously he put them on the opposite side of the world and in the North and South Hemisphere. I presume the assumption was that you would have lots of telescope time, but it turns out in Australia where the telescope is, it's always cloudy. So we have about 1 1/3 2-meter telescopes. This is known as the Falks Telescope Project. We've been running it ever since we acquired it. Over 650 different named schools have used these telescopes. This year, for instance, they'll have lots of repeats and some new people, so about 250 schools will end up using the telescope this year. These classes are typically done in classes, so there's probably 20 to 30 people in the class, and they typically go on the telescopes 2 or 3 times. So there's a lot of contact hours, a lot of exposure for this particular project, and it's spread slowly to Europe. It's heavily used in Russia, in these very elite math schools for advanced teenagers. However, we've discovered that if you look at what they're doing, it's very clear that what's happening is the professional astronomers have co-opted the kids in the classroom, and they are having the kids do their observing for them, do their science for them. And I just think that's great, because that means those students are interacting with professional scientists, which is sort of what we want. The way this works right now is it starts with pretty pictures. You get a half hour on the telescope. You sort of say, I want to go here. You say, I want a red filter. I want a 3-second exposure. You sit there and wait, and a JPEG comes up, and you go, wow. And then you do it again, and you do it again, and 30 minutes is up. What we found in general is that's a great thrill, but after a while, if you try to do science, it doesn't work very well. And the only control panel they have is this panel that allows you to sort of take pictures in a very manual way. You can get the scientific images from our server about 20 minutes later, but what we noticed is only about 40% of the scientific images were ever subsequently downloaded. So basically 60% of the time that's devoted to 2 telescopes that cost over $25 million apiece when they were originally built basically go to produce a JPEG, a wow, and that's it. So that doesn't sound like a very cost-effective program, at least to me. So I said before, we're privately funded. We don't receive more than a nominal amount of money from the NSF, mostly programs that our people that we've hired brought with them. We have a 20-year funding endowment in place, and this is extraordinary for science. I mean, it's very rare when you'll find any scientific institution that has a mission that is funded. And the objective of the scientists is to do science, not spend their day writing grants to get more money so that they can kind of pay themselves. So this is a very different thing. We have astronomers here in Goleta. We have a few in England, but our whole focus is here, Santa Barbara or Goleta. It's always tricky to know what to put on the address. We're closely associated with University of California, of course, in Santa Barbara. We're in one of their buildings, in essence. We're a sublessor in one of the buildings. Our staff are adjunct faculty over there, and all of us are technically staff. I happen to be a research fellow, but that's sort of irrelevant. What it really gets me is the ability to get a faculty parking permit so I can actually park over there. It doesn't, however, prevent me from getting tickets, even though I park in faculty places with a faculty permit. So I support the university through my parking ticket payments. We have a very serious science staff. Dr. Tim Brown is